So let's talk about what happens when we're graphing these things, when we're graphing a line or graphing a parabola. Ooh, wait, you know what? Let's go back a little bit. I'm going to show you how to do this on Desmos just so you can see it in real time. So let's grab our Desmos and let's type in the linear regression. I'm going to hit the plus sign. I'm going to hit the table. I'm going to enter our points, which were 2 for the x, 3 for the y, and 4 for the x and the y. When I hit the little line that goes through the points there, it says linear regression, and look under equation. We definitely see right about here the y equals 1/2 x plus 2, which is exactly what we found by hand. So, yeah, when we're graphing things, like what the actual heck is happening, right? We have to remind ourselves that a graph is just a picture of a functions. The input x values are plotted along the x-axis, and the y values, or the f of x values, the function evaluated at x values, are graphed along the y-axis. So for example, if I make myself a little xy coordinate plane, if I have the function y equals 2x, and I'll make a little t-chart for myself. If I put in a -2 for the x, I'll get out a -4 for my y from that equation. If I put in a -1, I'll get out -2. If I put in 0, I'll get out 0. If I put in 1, I'll get out 2. If I put in 2, I'll get out 4. And then I can go ahead and plot these points. Go over to -2 on the x-axis, down to -4 on the y-axis, put a point there. Go over to -1, -2, put a point there. 0, 0, put a point there. 1, 2, put a point there. 2, 4, put a point there. Look what shape I am making. I'm making a line. So that graph basically represents the infinite number of inputs and outputs that will work in this linear equation. You can even say, oh, Donna, what if I put in 1/2? That was not a point that you had on your little t-chart, but look what it says we will get out. We'll get out 1. And is that true? If I put in 1/2 here, will I get out 1? Well, absolutely. If I put in 1/2 for my x value, I get out 1 for my y value, and that's why that point is on the graph. So again, if a point lies on the graph of a function, it's because the x and y of that point work in the equation. It's a very important concept to start to think about for the SAT. So let's give ourselves a little information about the xy coordinate plane. So this is called the x-axis. This is called the y-axis. Where they intersect is called the origin, and it's the point 0, 0. It doesn't go right or left, doesn't go up or down. Everywhere in the xy coordinate plane, you can figure out where it is by giving it an x and a y coordinate. So say I've wanted to call out this point right here. Well, I'll say from the origin, I'll go right to, and then up to. So because I went right to, that's an x value, so that's +2. And then I went up to, so that's a +2y value. So that would be the point 2, 2. The xy coordinate plane is broken up into 4 what are called quadrants by the axes. They start in the upper right, that's the first quadrant. In the first quadrant, x and y are both positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is negative, y is positive. In the fourth quadrant, x is positive, y is negative. So keep in mind, it starts in the upper right and goes counterclockwise. So again, when we graph a function, you'll notice this is just a little more filled out version of what I was showing you before. If we take the equation y equals 2x, you put in some x's, you get out the y's, you put a point in all those places, connect them, and you have a picture of your function, right? Basically, if we were to fill in all the possible x's and their corresponding y's, then they get crazy, horrible, nasty decimal numbers. It would come out to be all these points on the line. So again, we're having this idea, if a point lies on the graph of a function, the coordinates of that point satisfy the function's equation. So let's see how this would work on a more abstract problem. So this says the figure below shows the graph y equals f of x. All that means is we have a function here. If you don't know what functions are, please watch the function video and you can come back to this. But functions mean if you put in an x value, you do the function to it, and it gives you an output, a y value. So when we're looking at this here, it says, what is the value of f of 1? So remember, that 1 there, it's inside the parentheses, and who's inside the parentheses? Well, that's an x value. X is 1. However, they're not asking us what x is. They're asking us what the function evaluated at x is. Once I put 1 into the function and I do the function to it, what's my output? Now, if I look at this graph here, I can actually tell what it is. Why? I go over to where my x value is 1. It's 1 along this whole vertical line. The question is, according to the graph, when I put in a 1, what was my output? Well, we look at this point right here. When I put in a 1, I get out a 3 according to this point, which tells us when my x is 1, my f of 1, or my output from that, is 3. Let's try a couple more. What then would f of 0 be? When my x value is 0, remember, I'm going to be on this vertical line. What's my corresponding y value? Well, a lot of people say, Donna, isn't it 0? Because look, that's the point 0, 0. But remember, that's not the point on the graph. When I look at this x value, the point on my graph that has that x value is right here at a y value of 1. So f of 0 equals 1. Now, what about if I said f of, I don't know, -1? Now I'm putting in -1 for my x value. Going to the left 1, that's going to be this vertical line right here. What's my y value of the graph doing there? Well, the y value of the graph is right here on the x-axis, so I know my y value is 0. Now, what about f of, say, 2? Well, now I'll go 2 to the right, boom, boom, and I'm going to be right here. I'm going to draw my little vertical line. And look, it intersects the graph right here. That is the point on the graph where the x value is 0. What's the y value? Well, it goes down 1 from the x-axis, so it would be -1. And what if I'm thinking about f of 1? What would f of 1 be? Well, now I just go to the right 1 from the origin, and I draw my vertical line. Remember, we saw this guy before. It was 3. Or what if I wanted f of 3? Maybe try to pause the video and see what you get when you do that. But if I go over 1, 2, 3, this vertical line is the line x equals 3. Look where it intersects. It intersects at -2. So that, again, would be the point 3, -2, meaning when my x is 3, my y was -2. If I input a 3, I get out a -2. So this can also help us kind of look at function notation a little bit better, that if f of a equals b, the idea that if the point AB is on the graph, then if you evaluate the function at A, you get B. Same thing here. If you evaluate the function at A and get B, then you know the point AB will be on the graph because it's a picture of all the inputs and their corresponding outputs.